It began as a whisper of radio static, a distant pulse echoing through the void. In the late 1950s, before humanity had ever seen Earth from above, two nations stood on the edge of a new kind of war, one that would not be fought on land or sea, but in the infinite darkness beyond. In just over a decade, human beings would go from firing crude missiles across deserts to walking on the moon, an evolution so abrupt, so audacious, that even those who made it happen could barely comprehend its pace. But behind the triumphs, behind the famous words, "one small step for man," lay a web of ambition, fear, and breathtaking risk. The story of Apollo was never just about exploration. It was about survival. The Cold War had divided the world, and both superpowers, the United States and the Soviet Union, saw space as the ultimate proving ground. To control the heavens was to control the future. Every rocket launch, every satellite, every astronaut was a signal to the world. We are stronger, faster, and smarter than you. When the Soviets shocked the world with Sputnik in 1957, a beeping metal sphere no larger than a beach ball, the illusion of American dominance cracked. If Moscow could launch an object into orbit, it could also drop a bomb from space. Panic swept across the United States. Suddenly, space was no longer a dream. It was a matter of national defense. Within months, laboratories that once designed jet engines and missiles were turned into centers of cosmic ambition. The newly formed NASA inherited the urgency of a nation terrified of falling behind. It was not the curiosity of science that fueled its early years, but the fire of rivalry. And yet, out of that fear, something extraordinary was born. Engineers who had once built weapons began building bridges to the stars. Within a few years, the sound of rocket engines replaced the drumbeat of nuclear tension. But this wasn't a straight path to glory. Every launch carried not only human courage, but the possibility of disaster. Rockets exploded. Missions failed. Astronauts nearly died. And all the while, the world was watching, a global audience hypnotized by the spectacle of mankind's most daring gamble. By the time President John F. Kennedy declared, "We choose to go to the moon," America had sent only a handful of men briefly into space. No one knew if it could be done. No one knew if it should be done. Yet the declaration set in motion the greatest engineering challenge in human history, a race not only against the Soviets, but against time itself. This is the story of how a young space agency, born from Cold War paranoia, transformed into a symbol of human aspiration. How test pilots became pioneers, and how science, politics, and dreams collided to propel humanity beyond the cradle of Earth. It's a story of triumph built on tragedy, of men who risked their lives for something greater, and of a planet that looked up one night and saw one of its own standing on another world. And yet, for all that was achieved, there are questions still whispered among historians and scientists alike. Why, after reaching the moon, did we stop? What did we truly discover up there? And what might still remain unseen, buried beneath the lunar dust? As we step back into this chapter of history, we'll unravel not just the story of the Apollo missions, but the deeper narrative of how humanity learned to leave home and what it cost us to touch the stars. Part 1. The Dawn of the Space Age. It was October 4, 1957. In the quiet evening sky above Kazakhstan, a small sphere no larger than a beach ball cut across the darkness, sending out a rhythmic signal. Beep, beep, beep. Those simple pulses would change the world forever. The object was Sputnik 1, the first artificial satellite in human history. For the Soviet Union, it was a symbol of triumph. For the United States, it was an existential shock. In that moment, a new kind of race began, not for territory, not for ideology, but for the very future of humanity's place in the cosmos. Before Sputnik, space was a concept reserved for dreamers and scientists, the realm of science fiction, not statecraft. But in the aftermath of World War II, the great powers had inherited something far more tangible: rocket technology. And at the center of it all stood men like Wernher von Braun, a German engineer whose V-2 rockets had once rained destruction across Europe. Now, under the American flag, von Braun and his team were building machines designed to reach not cities, but the stars. In the United States of the 1950s, life seemed stable and prosperous. Factories that once produced tanks now made cars and televisions. The war was over and America reigned supreme. But beneath the comfort of suburban calm, the Cold War was tightening its grip. Nuclear arsenals grew, and paranoia seeped into every level of society. When the Soviets launched Sputnik, it shattered the illusion of safety. Radio stations across America interrupted their broadcasts to announce the news. People rushed outside, scanning the night sky for the faint glint of the satellite as it passed overhead. It wasn't just a scientific feat. It was proof that the Soviet Union had the power to reach anywhere on Earth. 2 days after Sputnik's launch, the Soviets detonated a massive thermonuclear bomb. To the American public, the connection was obvious. They could strike from space. The age of intercontinental missiles had arrived, and the fear was immediate. In December of that same year, the United States prepared its own satellite launch, the Vanguard project. The launch was televised live, coast to coast. But as millions watched, the rocket barely rose a meter before collapsing in a fireball. The world laughed, the Soviets gloated, and America, humiliated, demanded answers. It was at that moment that President Dwight D. Eisenhower authorized a new civilian agency dedicated to space exploration, one that could restore national pride and coordinate the country's scattered research programs. Its name, NASA. By 1958, NASA was officially born, an organization forged not from curiosity, but from crisis. Its mission, to make sure the United States would never be caught unprepared again. Early on, the agency's goals were modest. Engineers focused on launching small satellites and testing experimental rockets. But soon, the political stakes grew higher. The Soviet Union had already placed a living creature, Laika the dog, into orbit, a feat that both captivated and horrified the world. If they could send a dog into space, could a human be next? The answer came in April 1961. A young Soviet pilot named Yuri Gagarin climbed aboard a spacecraft called Vostok 1. 108 minutes later, he became the first human being to orbit the Earth. When his capsule landed safely in a field near the Volga River, the space race was no longer a metaphor. It was real, and America was losing. 3 weeks later, astronaut Alan Shepard made his own flight aboard Freedom 7. It was brave, it was historic, and it lasted only 15 minutes. Shepard's capsule never even reached orbit. The contrast was painful. But as Shepard's capsule splashed down in the Atlantic, another voice was preparing to change the narrative. A young president, John F. Kennedy, stepped to a podium before Congress and made a promise that would define a generation. We choose to go to the moon, not because it is easy, but because it is hard. It was a declaration that seemed almost reckless. The United States had not yet perfected orbital flight, and now the president was vowing to send men to another world and bring them safely home before the decade was out. To engineers, it sounded impossible. To politicians, it sounded expensive. But to the world, it sounded like destiny. What followed was a mobilization unlike anything seen in peacetime history. Thousands of scientists, technicians, and pilots united by one purpose. The race was no longer about fear. It had become a test of imagination, courage, and the limits of what human beings could achieve. But beneath the soaring rhetoric and grand ambition, there lingered a darker truth. No one actually knew how to get there. Part 2, The Architects of the Impossible. When President Kennedy declared the goal of landing a man on the moon, America had only 12 successful satellite launches to its name. The idea seemed less like policy and more like prophecy. But at the heart of NASA's impossible mission stood a man who had dreamed of space long before it became a political battlefield. Dr. Wernher von Braun. Von Braun was a paradox, a visionary and a survivor. Once an engineer for Nazi Germany's V-2 rocket program, he had surrendered to the Americans at the end of World War II, bringing with him a team of specialists and a mountain of technical knowledge. Their deadly rockets had once leveled cities. Now, in a twist of history, their expertise would fuel humanity's journey beyond Earth. At the Redstone Arsenal in Alabama, Von Braun and his team began reimagining warfare's engines as instruments of exploration. The Redstone missile, originally designed for the Army, was soon modified into a space launcher. In 1958, one of these rockets carried Explorer 1, the first successful American satellite, into orbit. It was a small victory, but symbolically, it marked NASA's first step toward the stars. Yet, even as NASA celebrated, Von Braun knew the path ahead was treacherous. Building a rocket powerful enough to reach the moon was not just a matter of scale, it was a matter of survival. Every launch was an experiment with fire, every success balanced on the edge of catastrophic failure. In the early 1960s, two competing schools of thought divided NASA's engineers. One group favored the direct ascent method, build a massive, single rocket capable of flying directly to the moon, landing, and returning in one piece. It was simple in theory and utterly unworkable in practice. The required rocket would have been taller than the Statue of Liberty and too heavy for any launch pad in existence. Another faction proposed Earth orbit rendezvous, launching multiple smaller rockets, assembling them in orbit, and then heading for the moon. But this, too, introduced layers of complexity and risk that made many uneasy. And then came a third idea from an unassuming engineer named John Houbolt, working at NASA's Langley Research Center. Houbolt's plan was radical. Instead of landing the entire spacecraft, NASA could send a specialized vehicle, a lunar module, to detach, land on the moon, and then return to orbit to rejoin the command ship. The concept was called Lunar Orbit Rendezvous, LOR. When Houbolt first proposed it, his peers called it insane. Rendezvousing in lunar orbit was far beyond what NASA had achieved. Even docking two craft in Earth's orbit had never been done. Frustrated, Houbolt took a gamble. He bypassed the chain of command and sent a letter directly to NASA's top administrator, writing, "Do we want to go to the moon or not? If we do, then we must use lunar orbit rendezvous." His persistence paid off. One by one, the skeptics began to realize that LOR was not only feasible, it was the only realistic path to Kennedy's 1969 deadline. When Von Braun himself endorsed the plan, it became official. The moon mission would rely on three distinct spacecraft: the command module, the mothership that would orbit the moon; the service module, carrying engines and life support; the lunar module, a delicate, insect-like craft designed to land two men on the surface. To lift this entire assembly into space, Von Braun proposed something even bolder: a new rocket larger than any built before. It would be called Saturn. The first version, Saturn I, was a patchwork of existing technology, a cluster of modified fuel tanks and engines built to test the concept. On October 27, 1961, the first Saturn took flight. The launch pad shook, the ground thundered, and for the first time, everything worked. The rocket rose smoothly, flawlessly. A triumph for Von Braun's team and a sign that Kennedy's dream might not be impossible after all. But beyond the engineering marvels, there was a shift happening within NASA itself. The agency was evolving from a small, loosely organized bureau into a monumental national enterprise. At its height, over 400,000 people would work toward Apollo. Engineers, mathematicians, test pilots, and factory workers scattered across 20,000 companies and universities. Each component, each bolt, each line of code was part of a larger, almost mythical ambition: to prove that science, guided by courage, could outpace fear. Still, the stakes were astronomical. Every successful launch brought celebration. Every failure was a potential national embarrassment. The Soviets had not stopped advancing either. By 1962, they were launching multi-man spacecraft, keeping astronauts in orbit for days at a time, and even planning their own lunar ambitions. The pressure was relentless. For the Americans, the solution was clear. To reach the moon, they first needed to master the art of working and surviving in space. And so began a new chapter, one that would train a generation of test pilots to become astronauts, teach machines to rendezvous in orbit, and prepare humanity to take its first step toward another world. The name of that chapter was Project Gemini. Part 3, Project Gemini. The crucible of spaceflight. If Mercury had proven that humans could survive spaceflight, Project Gemini would determine whether they could live and work there. Between the fragile first steps of the early 1960s and the colossal ambition of Apollo, Gemini stood as NASA's bridge between dream and execution, a testbed for everything that needed to go right before anyone could walk on the moon. It was born out of urgency and fear. After Yuri Gagarin's orbital triumph and John Glenn's historic but brief flight, America was still behind. The Soviets had more time in orbit, more data, and more victories to show the world. If NASA couldn't master the mechanics of long-duration flight, orbital rendezvous, and extravehicular activity, spacewalking, the moon would remain beyond reach. Gemini's purpose was brutally simple: train the body, master the machine, and learn how to dance with gravity. The spacecraft itself was a leap forward. Sleeker, heavier, and far more advanced than Mercury, Gemini could carry 2 astronauts instead of 1. It had proper control thrusters, ejector seats, and a modular design that included a separate equipment section for fuel, oxygen, and power. It wasn't just a capsule. It was a small, maneuverable ship designed to practice every maneuver Apollo would later need. In the spring of 1965, NASA was ready. Gemini 3, crewed by Gus Grissom and John Young, lifted off from Cape Kennedy. It was the first spacecraft capable of changing its orbit mid-flight, proving that astronauts could maneuver freely in space rather than drift passively. It lasted only 5 hours, but it rewrote everything NASA knew about orbital flight. Still, Gemini's most iconic moment came with its next mission. Gemini 4, commanded by James McDivitt and Ed White, would attempt something no American had ever done before: a walk in space. On June 3, 1965, above the blue curve of the Pacific, Ed White opened the hatch and stepped out. Tethered by a thin lifeline, he floated into the void, sunlight glinting off his visor, his body turning slowly against the infinite black. He was weightless, free, and utterly alone, America's first spacewalker. White drifted with a handheld gas gun, laughing through his headset as Mission Control listened in stunned silence. "This is the greatest experience," he said. For 21 minutes, he moved in the vacuum as if born for it. But even this small triumph revealed how little NASA truly understood about the physical toll of working outside the spacecraft. White's suit swelled, his visor fogged, and he had to fight to close the hatch behind him. Still, to the world, it was a moment of awe. For the first time, television cameras showed an American moving freely in space. It was not just an experiment, it was a declaration. NASA was catching up. Gemini missions followed in rapid succession. Each flight was a rehearsal, a challenge, a lesson written in fire and sweat. Gemini 5 tested fuel cells to generate electricity, enabling missions to last over a week, a critical step for lunar voyages. Gemini 6 and 7 achieved something even more extraordinary: a rendezvous between 2 spacecraft in orbit, their silver hulls drifting only meters apart, moving at 28,000 kilometers per hour. For engineers, it was a mathematical ballet. For the world, it was proof that precision in space was possible. Astronaut Wally Schirra, commanding Gemini 6, reported calmly, "We're eyeball to eyeball. Humanity had just learned to meet in the heavens." But the missions were not without peril. Gemini 8, commanded by Neil Armstrong and David Scott, successfully docked with an unmanned Agena target vehicle, another first. But moments later, disaster struck. A stuck thruster sent the combined spacecraft into a deadly spin. The astronauts could see the stars blurring into a single glowing ring. Only Armstrong's composure and rapid decision-making saved them. He manually separated from the Agena and stabilized Gemini 8, performing one of the most extraordinary recoveries in the history of flight. It was a narrow escape, and a grim reminder that the frontier NASA sought to conquer could kill as easily as inspire. The Gemini program also revealed the brutal physical and psychological costs of space travel. Long-duration flights left astronauts weak and disoriented. The smallest errors in navigation or timing could mean drifting forever in the void. Spacewalks proved far harder than expected. Astronauts reported exhaustion, nausea, and loss of orientation. To solve this, NASA began training crews underwater, using pools to simulate the weightlessness of orbit. Buzz Aldrin, a newcomer to the astronaut corps and a trained engineer, excelled at these exercises. He developed new techniques and tools that made working outside the spacecraft far more manageable. When he finally performed his own spacewalk during Gemini 12, Aldrin demonstrated near-perfect control. For the first time, NASA understood how humans could operate efficiently in space for extended periods, a revelation that would directly shape the Apollo moonwalks to come. By the time Gemini ended in 1966, NASA had checked nearly every box on its long list of unknowns. They had achieved orbital rendezvous, tested fuel systems, practiced spacewalking, and verified the performance of guidance computers and suits. The training wheels were off. Gemini was more than a program. It was a crucible, a proving ground where courage and science fused. Every failure had been dissected, every success earned through sweat and fear. Now, the stage was set for Apollo, the greatest gamble of them all. NASA had the rockets. It had the pilots. It had the knowledge. But what it didn't know was that its first great tragedy was waiting just around the corner. Part 4: Fire in the Capsule. The Apollo 1 disaster. By 1967, the United States stood on the edge of its greatest leap in history. NASA's Apollo program had moved from blueprints to reality. The new Saturn rockets had thundered successfully off their launch pads, test after test. The hardware worked. The science was catching up. The astronauts, veterans of Mercury and Gemini, were ready. But in the race to beat the Soviets to the moon, the schedule was merciless. Every department was under pressure. Every engineer knew the stakes. Each delay risked political backlash, loss of funding, or worse, humiliation on the global stage. The first manned Apollo mission, Apollo 1, was meant to be a routine test. A rehearsal, not a flight. The crew, Virgil Gus Grissom, Ed White, and Roger Chaffee, were three of NASA's finest. Grissom, one of the original Mercury 7, had flown the first Gemini mission. White was America's first spacewalker. Chaffee, the rookie, was eager to join the pantheon of astronauts who had defied gravity. Their mission would be simple: sit inside the Apollo command module, sealed and powered, while technicians ran through a simulated countdown. The rocket itself was empty of fuel. The test was meant to ensure that the spacecraft systems worked independently, a plugs-out procedure, as engineers called it. But the Apollo capsule was still in its infancy. Its wiring was a maze of unshielded cables. Its interior lined with Velcro, nylon netting, and flammable materials. And, like Mercury and Gemini before it, the cabin was filled with pure oxygen, a decision made for simplicity, not safety. On January 27, 1967, the astronauts climbed into their seats atop the unarmed Saturn V rocket. The air was heavy with tension and static. Grissom's voice, calm but sharp, came through the comms. "How are we going to get to the moon if we can't talk between two buildings?" Communications were glitchy. Minor issues delayed the countdown again and again. Outside, engineers grew restless. Inside the sealed capsule, temperatures were rising. At 6:31 p.m., a burst of static cut across the channel, followed by Grissom's scream, "Fire in the cockpit!" What happened next took only seconds. In the oxygen-rich atmosphere, even the smallest spark became an inferno. Flames raced through the cabin, feeding on every inch of fabric and wiring. The pressure inside the capsule surged, locking the inward opening hatch in place. The crew's desperate attempts to open it were futile. By the time technicians reached the capsule, it was already too late. In just 17 seconds, Apollo 1 had become a tomb. Grissom, White, and Chaffee were gone. When the fire was finally extinguished, the scene inside was devastating. NASA's dream of the moon lay charred on the launch pad. Three men had paid the price for a system obsessed with progress. The public reaction was immediate: grief, anger, disbelief. For the first time, America's love affair with the space program faltered. Congress demanded answers. Newspapers ran headlines calling Apollo a death trap. Behind closed doors, NASA's top officials gathered in silence. The question wasn't whether the program would continue, but whether it should. The investigation that followed was exhaustive. Engineers worked night and day, reconstructing the sequence of events. It was determined that an electrical short, likely caused by frayed wiring, had ignited a piece of flammable Velcro beneath Grissom's seat. The pure oxygen atmosphere turned a spark into a firestorm. The conclusions were damning. The capsule's design was fundamentally unsafe. Every layer of procedure, from material selection to emergency egress, had failed the crew. NASA's Director of Flight Operations, Gene Kranz, addressed his team shortly after the tragedy. His words became legend. From this day forward, flight control will be known by two words: tough and competent. He meant it as both an oath and a warning. For months, all manned spaceflights were suspended. The Apollo Command Module underwent a complete redesign. Engineers replaced flammable materials with non-combustible fabrics, shielded every wire, and re-engineered the hatch to open outward in seconds. The loss of Apollo 1 scarred NASA deeply, but it also changed it forever. The tragedy stripped away any illusions of infallibility. From that point on, safety and precision became sacred. Meanwhile, halfway around the world, the Soviet Union suffered its own catastrophe. In April 1967, cosmonaut Vladimir Komarov was killed when his parachutes failed to deploy during the return of Soyuz 1. The parallels were grim. Both nations were learning, at a deadly cost, that spaceflight was an unforgiving teacher. And yet, out of those ashes, determination grew. America mourned, but it did not retreat. The astronauts who trained alongside the fallen men, Frank Borman, Jim Lovell, Neil Armstrong, swore privately that they would see the mission through. The program would rise again, stronger, safer, smarter, and when it did, the entire world would be watching. But before NASA could aim for the moon again, it had to prove that the Saturn V, the largest rocket ever built, could actually fly. That proof would come with a new mission and a new kind of courage. Part 5. The Giant Awakens. The birth of the Saturn V in the aftermath of Apollo 1. NASA was a wounded organization. Humbled, haunted, but unbroken. Every engineer, every flight director, every astronaut knew that if they were to honor Grissom, White, and Chaffee, they had to make Apollo safer, smarter, and stronger than ever before. And at the center of that transformation stood a machine unlike anything the world had ever seen. A rocket so powerful it seemed almost mythological. It was called the Saturn V. The concept had existed on paper for years, born from the mind of Wernher von Braun and his team at the Marshall Space Flight Center in Huntsville, Alabama. But now, after the tragedy, the Saturn was no longer just a vehicle, it was a symbol. It had to work. It had to fly. Because if it failed, the dream of reaching the moon would die with it. Standing 363 feet tall, weighing more than 6 million pounds when fueled, the Saturn V was a skyscraper of fire and steel. It was designed in 3 stages, each more complex than the last. The first stage, known as the SIC, carried 5 enormous F-1 engines, each capable of producing 1.5 million pounds of thrust. Together, they would lift the rocket off the pad in a hurricane of noise and flame. The second stage, powered by J-2 engines, would take over high in the stratosphere. The third stage, delicate and precise, would provide the final push, propelling the spacecraft beyond Earth's gravity and on its way to the moon. Every part of it had to work perfectly. There would be no second chances. The testing program for the Saturn V was brutal. Engineers at Marshall fired engines for hours, pushing them to their limits. They shook entire rocket sections with hydraulic arms to simulate the stress of launch. They filled tanks with liquid hydrogen so cold it could shatter metal. And through it all, von Braun's philosophy guided the team. Test what you fly what you test. But there were skeptics, even inside NASA. The idea of launching a fully assembled Saturn V on its first test seemed reckless. Traditionally, rockets were tested one stage at a time. Von Braun's new method, called all-up testing, would ignite every stage on the very first flight. If anything went wrong, the entire vehicle could be lost. Still, there was no time left for half measures. Kennedy's 1969 deadline loomed over every meeting, every design, every checklist. And so, on November 9, 1967, under a pale Florida sky, the first Saturn V stood ready on Launch Complex 39A, its white frame gleaming like a monument to both ambition and fear. The mission was designated Apollo 4. No crew, no lunar module, just the rocket itself, the most powerful machine humanity had ever built. As dawn broke, the rocket's skin began to sweat with frost. The cryogenic fuel inside, liquid oxygen and hydrogen, chilled the metal to its limits. Inside the firing room, rows of controllers watched the countdown. No one spoke. Every breath felt heavier than the air. Then, the voice of the launch director cut through the silence. Ignition sequence start. The ground trembled. The 5F-1 engines roared to life, each one a controlled explosion. Flames hundreds of feet long erupted from the base. The rocket seemed to pause for a heartbeat, as if deciding whether to obey gravity or defy it. Then, slowly, impossibly, it began to rise. At that moment, every doubt evaporated. The Saturn V was alive. As the rocket climbed, its thunder rolled across the Florida swamps, shattering windows miles away. Engineers watched their monitors, tracking pressures, temperatures, and vibrations. Each reading confirmed what they scarcely dared believe: the rocket was performing flawlessly. 12 minutes later, the Saturn V was in orbit. 2 hours after that, it reignited its third stage and sent its test capsule hurtling nearly 18,000 kilometers away from Earth, farther than any spacecraft had ever traveled before. When the capsule splashed down safely in the Pacific, Mission Control erupted in applause. Apollo had been reborn. The success of Apollo 4 proved that the giant could fly, and that humanity, for the first time, had a machine capable of taking it to another world. But one crucial piece was still missing: the lunar module itself, the fragile craft that would carry 2 men down to the moon's surface. Its construction had been plagued by delays and redesigns. It was unlike anything ever built, light enough to fly in 1/6 gravity, yet strong enough to protect its crew from death. The pressure on NASA's contractors was immense. The world was watching. The Soviets were still silent about their own lunar plans, but American intelligence suggested they were racing toward a similar goal. If NASA was to stay ahead, every component had to work perfectly and together. The next missions would prove whether the new Apollo spacecraft could truly function in space. Whether its engines would fire in orbit, whether its systems could support a crew, and whether humanity could endure the long journey through the emptiness between Earth and the Moon. And to do that, NASA would have to fly again, this time with men on board. The name of that mission would be Apollo 7. Its success or failure would determine whether the dream of walking on the Moon would live or die. Part 6, Apollo 7, the rebirth of manned spaceflight. By the autumn of 1968, the stakes could not have been higher. 19 months had passed since the Apollo 1 fire, and NASA had yet to launch another astronaut into space. Congress was growing impatient, public support was wavering, and the Soviet Union showed no sign of slowing its silent progress. If the next mission failed, the United States might lose the race to the Moon before it ever truly began. The burden of redemption fell on the shoulders of 3 men: Walter Schirra, Don Isley, and Walter Cunningham, the crew of Apollo 7. They would fly the first manned test of the redesigned Apollo spacecraft aboard the smaller Saturn IB rocket. It would not be a flight to the Moon, only a mission to Earth orbit, but the importance of their success was absolute. On the morning of October 11, 1968, under the cloudless skies of Cape Kennedy, Apollo 7 roared to life. From the launch pad, the Saturn IB rose like a spear of fire, carrying with it not just 3 astronauts, but the hopes of an entire agency. Inside the command module, Schirra's calm voice cut through the radio static. "She's riding like a dream." For the first time since tragedy had struck, NASA dared to exhale. The Apollo Command and Service Module, CSM, was a marvel of engineering, stronger, safer, and infinitely more sophisticated than the Gemini capsules that came before it. The hatch could now be opened in seconds. Its interior wiring was shielded and fire-resistant. Every switch, valve, and control had been tested, retested, and tested again. This was the machine that would one day carry men to the Moon, and now, finally, it was proving itself. But even in orbit, perfection was an illusion. Within the first day, Skira developed a head cold, an annoyance on Earth, but in zero gravity it became a misery. His sinuses couldn't drain. His ears clogged. Breathing was painful. Soon, Isley and Cunningham were sick as well. The crew, confined in the tight metallic shell, grew irritable. Small frustrations, food that wouldn't rehydrate properly, communications lag, endless checklists became daily battles. Mission Control in Houston could sense the tension. Skira, a veteran of Mercury and Gemini, was known for his precision and stubbornness. He clashed with controllers over schedules, refused unnecessary TV broadcasts, and at one point openly ignored orders. It was a difficult mission, but technically it was flawless. The spacecraft performed beautifully. The service module's main engine, the powerful SPS, fired 8 times in orbit without a single error. The guidance systems worked perfectly. The life support and power systems, crucial for future lunar flights, were stable and reliable. NASA was finally learning to trust its machines again. And despite the friction, Apollo 7 made history in another way. It hosted the first live television broadcast from an American spacecraft. Viewers at home saw the astronauts floating weightlessly, their faces tired but proud, holding up handwritten signs to the camera that read, "Hello from the lovely Apollo room." It was a quiet moment of connection, the first time humanity truly saw what life looked like beyond Earth. After 11 days in orbit, Apollo 7 returned safely to Earth, splashing down in the Atlantic Ocean. The re-entry was smooth, the heat shield intact, the parachutes deployed perfectly. For NASA, the relief was overwhelming. The agency's darkest chapter had finally begun to heal. But behind the applause, there was tension. Skira's defiance during the mission had frustrated his superiors. Though he had delivered a flawless flight, it would be his last. Neither he nor his crewmates would ever fly again. Still, they had achieved what mattered most. They had proven that the redesigned Apollo spacecraft was safe, functional, and ready for the next great challenge. That challenge would come sooner than anyone expected. Only weeks after Apollo 7's return, a decision was made that would shock even the astronauts themselves. Intelligence reports suggested that the Soviet Union was preparing a bold new step, a manned flight around the moon before year's end. If that happened, the US would lose its final advantage. So NASA took an extraordinary gamble. They would send the next crew, Apollo 8, not just into orbit but all the way to the moon. No lunar module, no backup plan. Just 3 men, a spacecraft, and a single mission, to prove that America could reach another world before anyone else. It was the most daring spaceflight ever attempted, a leap into the unknown. If Apollo 8 failed, it could end the program forever. If it succeeded, it would change human history. As 1968 drew to a close, the world watched the launch pads of Florida, unaware that humanity was about to leave Earth's orbit for the very first time. Part 7, Apollo 8. The voyage around the moon, December 21, 1968. The morning sky over Cape Kennedy shimmered with cold winter light as 3 astronauts, Frank Borman, Jim Lovell, and William Anders, climbed into their spacecraft atop the towering Saturn V. Their mission, Apollo 8, was unlike any before it. They would not test systems, rendezvous in orbit, or simulate procedures. They would leave Earth's gravitational hold entirely, becoming the first humans in history to travel to another world. It was, in every sense, a gamble. Just months earlier, the same rocket had misfired during a test flight, shaking itself apart. The lunar module, the craft meant to land on the moon, was still unfinished and untested. But intelligence from Washington was clear. The Soviets were preparing their own lunar flyby. If NASA waited, they would lose the race forever. So, in one of the boldest decisions in the history of exploration, NASA changed the mission plan. Apollo 8 would not orbit Earth. It would go straight to the moon. When the countdown reached 0, the Saturn V roared to life. 5 F-1 engines thundered across the Florida coast, each explosion echoing like the heartbeat of an empire. From the control room, veteran flight director Gene Kranz watched the telemetry screens flicker with data. Everything looked perfect. Humanity was on its way to the moon. "We have liftoff," called the announcer, his voice trembling slightly. "We have liftoff of Apollo 8, man's first journey to the moon." As the rocket climbed, Borman's voice came through the radio. "She's looking good." The world exhaled. 11 minutes later, the spacecraft settled into Earth orbit. For 2 revolutions, the crew and mission control checked every system. Then came the crucial call. TLI, translunar injection. If the third stage's engine fired correctly, Apollo 8 would break free from Earth's gravity. If it didn't, the mission and perhaps their lives would be over. "Go for TLI," came the command from Houston. The engines ignited, and the spacecraft accelerated, faster, farther, until the blue curve of Earth began to shrink. Then suddenly they were free. For the first time in history, human beings were traveling through deep space. At first, everything was silent except the hum of instruments and the soft rustle of air inside their helmets. Beyond the windows, the stars were motionless and sharp, so numerous that the astronauts could no longer distinguish one constellation from another. Lovell, a Navy pilot, whispered over the intercom, "It's like someone turned off the universe and switched on infinity." 3 days later, the moon grew large in their window, pale, silent, and riddled with shadows. As Apollo 8 swung behind it, radio contact with Earth vanished. For 20 agonizing minutes, mission control could do nothing but wait. If the engine failed to ignite, the spacecraft would sail past the moon forever, lost in the dark. Then, through the static, a voice crackled back from the void. "Houston, Apollo 8. The good Earth is in view." The burn had worked. They were in lunar orbit. As they circled the moon, the astronauts peered down at a world no human had ever seen up close. They saw craters the size of cities, mountains rising like frozen waves, plains of ash that stretched beyond sight. It was alien, lifeless, and magnificent. Then, during their 4th orbit, something extraordinary happened. As Apollo 8 emerged from the moon's far side, Anders turned his camera toward the window and gasped. There, above the lunar horizon, hung Earth, small, delicate, blue and white, rising slowly into the black sky. The photograph he took, later known as Earthrise, became one of the most iconic images in human history. It showed our planet not as a collection of nations, but as a single fragile home adrift in an endless void. On Christmas Eve, as the world watched and listened live on television, the 3 astronauts read from the Book of Genesis, their voices echoing through the radio waves. "In the beginning God created the heaven and the earth." 500 million people listened in silence. In a year marked by war, assassinations, and division, humanity heard, perhaps for the first time, a message from beyond its own world. After 10 orbits of the moon, it was time to return home. Apollo 8's engine fired one final time, propelling the spacecraft back toward Earth. The trip was smooth, a serene glide through the cold vacuum. 3 days later, on December 27th, the capsule splashed down safely in the Pacific Ocean. The mission had lasted 6 days, 3 hours and 42 minutes. It had proven that humans could travel to the moon and return alive. More than that, it had given humanity a new perspective, one that would change how we saw ourselves forever. Frank Borman summed it up simply in his report to NASA. "We came all this way to explore the moon, and the most important thing is that we discovered the Earth. For the first time, the moon no longer seemed impossible. It was close enough to touch." The next mission, Apollo 9, would test the final missing piece of the lunar puzzle, the delicate spider-shaped craft that could land and lift off again, the lunar module. If it worked, humanity would be ready to take that final step. But in the vast laboratories of NASA, engineers still whispered of the unknowns. The dust, the gravity, the radiation. The moon was closer than ever, yes, but it was still a place no living human had set foot. And it was waiting. Part 8, Apollo 9, The Spider and the Gumdrop. By early 1969, NASA stood at the threshold of history, but one crucial test remained. They had sent men to orbit the moon and safely home again. They had proven the mighty Saturn V could fly. Yet no one had ever tested the craft that would actually land on the lunar surface, the fragile two-stage vehicle known as the Lunar Module, or LM. It was unlike anything that had ever flown before. Angular, skeletal, covered in gold foil, the LM looked less like a spacecraft and more like an insect, earning it the nickname Spider. It had no aerodynamic shape, no seats, no heat shield, and no backup parachutes. It was designed for one thing only: to land on the moon, where there was no air, no weather, and no second chances. The command module, nicknamed Gumdrop for its blue, capsule-like appearance, would remain in orbit. Together, the two would rehearse the delicate ballet of separation, docking, and engine burns that would later be performed in lunar orbit. Every maneuver had to work perfectly, because in space, even the smallest mistake could strand the crew forever. The crew of Apollo 9, James McDivitt, David Scott, and Rusty Schweickart, knew exactly what was at stake. Their mission would test not just the lunar module itself, but humanity's ability to control two separate spacecraft simultaneously. On March 3, 1969, beneath clear Florida skies, Saturn V SA-504 thundered to life. It was the first full launch of both Apollo vehicles together, and it marked the start of one of NASA's most complex missions. Within minutes, Apollo 9 was in orbit, the spacecraft systems humming as McDivitt and his crew began their long checklist of tests. For the first 2 days, they stayed docked, checking communications, life support, and propulsion systems. Then, on the third day, came the moment of truth. The crew sealed the hatches and detached Spider from Gumdrop, slowly drifting away. For the first time in history, humans were flying a vehicle designed solely for another world. McDivitt's voice came through the radio, calm but charged with excitement. "Okay, Spider's flying." Outside the window, the lunar module glimmered in sunlight, spindly, awkward, but alive. Using its small descent engine, McDivitt and Schweickart tested the LM's ability to maneuver independently, firing short bursts to simulate a lunar landing. The craft performed beautifully. But space is never without surprises. Schweickart, assigned to perform a spacewalk between the two vehicles, became violently ill early in the mission, likely due to space adaptation syndrome, what NASA would later call space sickness. His nausea forced a scaled-down version of the EVA. Still, he managed to step outside the LM's hatch, testing the portable life support system, the backpack that astronauts would wear on the lunar surface. It was bulky and unproven, but it worked, the final key to walking on the moon. For 5 hours, the astronauts rehearsed every procedure they could: descent, rendezvous, docking, and each time, the results exceeded expectations. Even after returning to Earth orbit, they pushed the spacecraft to its limits, firing the service module's big SPS engine again and again to simulate lunar return burns. Every system passed. When Apollo 9 splashed down in the Atlantic on March 13, 1969, NASA knew the hardware was ready. For the first time, every piece of the lunar mission, the rocket, the command module, the lunar module, and the crew had been tested in space. The road to the moon was now clear. The next flight, Apollo 10, would take the final step, flying the lunar module down to just 15 kilometers above the moon's surface before turning back. It would be a full dress rehearsal for the landing itself. But even as NASA prepared for that mission, the pressure was immense. President Kennedy's deadline, before this decade is out, was now only months away. The world expected success. The slightest failure could destroy the dream. And in the deserts of the Soviet Union, another race was quietly nearing its end. Their massive N-1 rocket, designed to rival the Saturn V, was suffering catastrophic explosions during testing. But no one at NASA knew that yet. To them, the race was still on, and the finish line was the sea of tranquility. Soon, 2 spacecraft would dance in lunar orbit, one dipping close enough to see the landing sites below. And then, if all went well, the next mission would carry the words that would echo forever. The Eagle has landed. Part 9, Apollo 10. The dress rehearsal for the moon, May 18, 1969. The morning air at Cape Kennedy shimmered with heat as a white giant stood poised against the blue. Another Saturn V. Another test. But this time, a mission that would bring humanity to the very edge of another world. Its name was Apollo 10, and its purpose was both simple and terrifying. To perform every single step of a lunar landing, except the landing itself. The crew, Thomas Stafford, John Young, and Eugene Cernan, were seasoned veterans, men who had already seen the world from orbit and now stood ready to gaze upon it from the surface of the moon. If Apollo 8 had proven that humans could reach the moon, Apollo 10 would prove that they could land there, in theory. The next mission, Apollo 11, would turn theory into history. But first, Apollo 10 had to survive the rehearsal. At precisely 12:49 p.m., the 5F-1 engines of the Saturn V ignited, unleashing a roar that rolled across the Atlantic. The rocket lifted slowly, majestically, shedding clouds of fire as it climbed into the heavens. Inside the capsule, Stafford's voice was calm and clipped. "We're off to see the wizard." The reference wasn't accidental. Their call signs were whimsical, almost childlike. The command module was named Charlie Brown, and the lunar module, with its spindly golden legs, was dubbed Snoopy. But beneath the humor was tension sharp enough to cut steel. 3 days later, after a flawless translunar injection burn, Apollo 10 entered orbit around the moon. From the small window of Charlie Brown, the astronauts could see the lunar surface passing silently below. Vast plains of gray dust, ridges that cast long shadows, and craters that looked like old scars. Then came the moment of truth. Stafford and Cernan floated into Snoopy, sealed the hatch, and separated from the command ship. As they drifted away, John Young's voice echoed softly through the radio. "We'll see you guys later. Don't go for the big one." That big one meant landing. They weren't cleared for that, not yet. But they would go close. Very close. Snoopy fired its descent engine and began to drop. The gray surface rose beneath them, faster than they expected. Mountains and shadows slipped by as they reached a perilous altitude, 15.6 kilometers above the moon. At that height, they could see the Sea of Tranquility below, the same place Apollo 11 would soon attempt to land. It was breathtaking and terrifying. Cernan later described it as the most beautiful desolation I've ever seen. Then suddenly chaos. As they prepared to test the ascent stage, Snoopy began spinning wildly. The controls jolted. The horizon blurred. Alarms blared. In the narrow cockpit, Stafford wrestled with the controls, shouting, "Son of a gun! What the hell's happening?" A switch had been set incorrectly, triggering a misfire in the guidance system. The lunar module pitched and rolled violently, tumbling over the moon's barren surface. One wrong move and they would have crashed. There would be no rescue. For a few harrowing seconds, the astronauts fought the spacecraft like a bucking animal, their heart rates spiking. Finally, Stafford managed to regain control, leveling Snoopy just in time. "We is go, baby," he radioed, laughing breathlessly. It was gallows humor, but they were alive. After completing their simulated landing, Snoopy's ascent stage fired, rejoining Charlie Brown in orbit. The docking was smooth, precise, a testament to NASA's training and technology. Then came the long journey home. Apollo 10 splashed down in the Pacific Ocean on May 26, 1969, after a flawless 8-day mission. They had orbited the moon 31 times, testing every maneuver needed for a landing. Every system had performed beautifully. NASA now had everything it needed. The engines worked. The modules worked. The rendezvous procedures were proven. All that remained was courage and luck. As the capsule was recovered by the aircraft carrier USS Princeton, the astronauts stood on deck, sunburned and grinning. Stafford turned to the reporters and said, "We've paved the way for the next crew. Tell Neil to take care of that last 50,000 feet." The next flight would not stop at 50,000 feet. It would go all the way down to the dust itself. In Houston, the mission planners worked through the night. Every checklist was rewritten, every timeline revised, every system inspected one last time. The world's eyes were already turning toward July 1969. The next rocket to rise from Florida's coast would carry Neil Armstrong, Buzz Aldrin, and Michael Collins, the crew of Apollo 11. Their mission would be humanity's greatest test. And if they succeeded, a voice from 240,000 miles away would soon speak the words that would echo through eternity. That's one small step for man, one giant leap for mankind. Part 10, Apollo 11. The Eagle has landed July 16, 1969. The Florida sky was a pale, cloudless blue. The heat shimmered over the marshes of Cape Kennedy, where 500,000 people gathered, families, scientists, soldiers, and dreamers. Their eyes fixed on a single white giant standing on the launch pad, the Saturn V. It was the most powerful machine ever built by human hands, and on this day, it would carry the hopes of all humanity. Inside its tiny capsule sat Neil Armstrong, Buzz Aldrin, and Michael Collins, 3 men who had trained for years, knowing that their journey could make them immortal or end in silence. Armstrong, the quiet engineer and test pilot, was commander. Aldrin, the precise and methodical lunar module pilot, was his partner for the descent. Collins, orbiting above in the command module, would ensure they could come home. At 9:32 a.m., as the world held its breath, the countdown reached 0. Ignition sequence start. 6, 5, 4, 3, 2, 1, liftoff. We have liftoff of Apollo 11. The ground trembled like an earthquake. A pillar of flame erupted beneath the rocket, blindingly bright against the morning sun. Children screamed, cameras clicked, and men who had built this machine wept openly as it rose, slowly, majestically, into history. Within minutes, Apollo 11 had cleared the atmosphere. The first stage detached and fell away. The spacecraft slipped into orbit, circling Earth once before firing its third stage engine for TLI, translunar injection. When the engines shut down, they were no longer bound to Earth. They were on their way to the Moon. 3 days later, on July 19th, the gray sphere filled their windows. For Michael Collins, piloting the command module Columbia, it was a sight both beautiful and humbling. The Moon looks like a vast expanse of nothing. No color, no motion, no life. On July 20th, Armstrong and Aldrin floated into the lunar module, call sign Eagle, and sealed the hatch. Collins, left alone in orbit, would later joke that he was the most isolated human being in history. The descent began. The Eagle separated from Columbia and began its slow fall toward the surface. In Houston, the room was silent except for the steady voice of Charlie Duke, relaying instructions from Mission Control. Telemetry showed that the craft was descending too fast. Then came a series of warnings: 1202, 1201, program alarm. Nobody had seen those errors before. For a few seconds, confusion rippled through the control room. The lunar module's guidance computer was overloaded. It was processing too many tasks at once. But the flight controllers quickly realized that the main systems were stable. Go, flight. Eagle, your go to continue. Armstrong's hands gripped the controls. The lunar surface rushed closer. Jagged boulders, deep craters, and a vast plain that didn't match the charts. The computer wanted to land them in a crater full of rocks the size of cars. He took manual control. Fuel was running low. Less than a minute's worth remained. In Houston, every heartbeat seemed to stop. The call-outs came fast. 60 seconds. 30 seconds. Then, Armstrong's calm voice broke the tension. Houston, Tranquility Base here. The Eagle has landed. The control room erupted in cheers and tears. Charlie Duke, struggling to keep his voice steady, replied, Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. After a short rest, the world prepared for the moment it had waited for since the dawn of history. At 10:56 p.m. Eastern Time, Neil Armstrong opened the hatch, climbed down the ladder, and stepped onto the powdery gray dust of the Moon. That's one small step for man, one giant leap for mankind. His footprint pressed into the soft lunar soil, a mark that, to this day, remains untouched. Moments later, Buzz Aldrin descended to join him, calling it magnificent desolation. Together, they planted the American flag, not as a symbol of conquest, but as Armstrong later said, for all mankind. They collected samples, deployed instruments, and moved cautiously, learning how to walk in 1/6 gravity. Above them, Michael Collins orbited alone, watching both the Earth and the Moon from a distance no one else could imagine. He later said, "I wasn't lonely. I felt like part of every human who had ever lived." After just over 21 hours on the lunar surface, Armstrong and Aldrin climbed back into the Eagle, leaving behind a plaque that read, "Here men from the planet Earth first set foot upon the Moon, July 1969 AD. We came in peace for all mankind." The ascent engine fired, and the Eagle rose silently from the surface, joining Collins in orbit. Soon, the three men were reunited and on their way home. On July 24th, after a fiery re-entry, Apollo 11 splashed down safely in the Pacific Ocean. The world celebrated not just a victory in the space race, but a triumph of imagination, science, and courage. From every continent, people looked up at the Moon, now no longer unreachable, and whispered the same thought, "We did it." But even as NASA basked in glory, its engineers and astronauts knew the story wasn't over. Landing once was an achievement. Returning again and again, exploring, experimenting, expanding would be the true measure of success. And in that pursuit, more missions would follow, some flawless, some nearly fatal, each one carrying humanity deeper into the unknown. The next, Apollo 12, would test whether lightning, luck, and precision could coexist in the vacuum of space. Part 11, Apollo 12, thunderstruck November 14, 1969. A low gray sky hung over Cape Kennedy as storm clouds gathered along the Florida coast. Lightning flashed in the distance, an omen that most launch directors would have taken as a warning. But NASA was on a schedule, and the second moon landing mission, Apollo 12, was ready. The crew, Charles Pete Conrad, Richard Dick Gordon, and Alan Bean, were a very different trio from the solemn pioneers of Apollo 11. They were jokers, test pilots with a sense of mischief and unshakable confidence. Conrad, the commander, was famously blunt and barely over 5 feet tall. When a journalist once asked if NASA had picked him because of his height, he replied, "No, they picked me because I'm perfect." At 11:22 a.m., the countdown reached 0. The Saturn V thundered to life, its white frame piercing through drizzle and gray mist. The rocket climbed, and then, just 36 seconds into flight, disaster nearly struck. A blinding flash lit the sky. Lightning hit the rocket, not once but twice. Inside the command module Yankee Clipper, every warning light came alive. The entire electrical system went dark. Telemetry flatlined. From the cockpit, Conrad's voice came through the radio, half laughing, half panicked. "We just lost the platform, gang. I don't know what happened." For a few terrifying seconds, the spacecraft was blind. The mission seemed doomed. But in mission control, a young flight controller named John Aaron remembered a similar anomaly from a test months earlier. Calmly, he said the now legendary phrase, "Flight, try SE to AUX." The command baffled most of the team, even Conrad, who shouted, "What the hell's that?" But Alan Bean knew. He reached over and flipped the tiny switch on his console. Instantly, the telemetry screens flickered back to life. Apollo 12 was alive again. As the rocket continued upward, a second surge of lightning struck, but the systems held. The Saturn V delivered the spacecraft into orbit, battered but unbroken. Against all odds, the mission was still a go. 3 days later, Apollo 12 arrived in lunar orbit. The crew prepared for descent. Conrad and Bean transferred into the lunar module Intrepid, while Gordon remained behind in Yankee Clipper, photographing the surface and running experiments. When the descent engine fired, Conrad couldn't resist cracking a joke. Stepping down the ladder, he shouted, "Whoopee! Man, that may have been a small one for Neil, but that's a long one for me." Laughter echoed through mission control, the perfect contrast to Armstrong's solemn tone months earlier. The landing was flawless, precise to the meter. Apollo 12 touched down just 200 meters from the target, the unmanned Surveyor 3 probe which had landed 2 years earlier. For the first time, humans were able to visit a robot they had previously sent to another world, a quiet handshake across missions. Conrad and Bean spent over 31 hours on the moon's ocean of storms, setting up experiments, collecting samples, and taking photographs with the ease of seasoned explorers. The atmosphere was lighter, more playful than Apollo 11. At one point, Bean accidentally pointed the color TV camera at the sun, burning out its sensor, cutting off the live feed. He laughed it off, saying, "Well, that's one way to stay off television." Despite the mishap, Apollo 12 achieved every goal. It proved that NASA could land with pinpoint accuracy, that the lunar surface could support more extended work, and that even lightning couldn't stop the Saturn V. When Intrepid's ascent stage fired to rejoin Gordon in orbit, the moon receded quietly beneath them. Their footprints left beside the old Surveyor probe, 2 generations of exploration sharing the same patch of dust. On November 24th, Apollo 12 splashed down safely in the Pacific Ocean, ending a mission that began in thunder and ended in triumph. But as the spacecraft was hoisted aboard the recovery ship, few knew that the next mission, Apollo 13, would push NASA closer to the edge of disaster than any before it. For now, the world still celebrated, believing the moon had been conquered, the risks mastered, and the era of tragedy behind them. They were wrong, because just a few months later, as the world watched in awe once again, a calm voice from deep space would say words that froze humanity in its tracks. "Houston, we've had a problem." Part 12, Apollo 13. Houston, we've had a problem, April 11, 1970. At Cape Kennedy, the Saturn V stood ready once again, its white frame gleaming under the Florida sun, a familiar sight to a world growing used to lunar triumphs. But beneath the confidence lay fatigue. The public was no longer captivated. Moon missions had become routine. Newspapers buried the launch of Apollo 13 on their back pages. No one, not even NASA, suspected that this routine flight would become the most perilous journey in the history of space exploration. The crew was led by Jim Lovell, a veteran of Apollo 8, alongside Fred Hayes and Jack Swigert, who had replaced the original command module pilot just 2 days before launch after his crewmate was exposed to measles. They were competent, confident, and ready for what was expected to be a near-perfect mission, the third lunar landing. At 2:13 p.m., the rocket ignited, its engines shaking the ground as Apollo 13 began its journey. As the spacecraft rose through the atmosphere, lightning flashed across the sky, a haunting echo of Apollo 12's near miss. But this time there were no electrical issues. Within minutes, the crew was in orbit, then on their way to the moon. For the first 2 days, everything was nominal. Lovell joked with mission control. Hayes filmed the inside of the spacecraft for television audiences. Swigert handled navigation and ran system checks. The astronauts floated weightlessly in the narrow cabin, unaware that disaster was quietly forming in one of the spacecraft's 2 oxygen tanks. Then came April 13th, a date that would live forever in NASA's memory. At 55 hours and 54 minutes into the flight, Mission Control requested that the crew stir the cryogenic oxygen tanks, a routine procedure. Swigert flipped the switch. A loud bang echoed through the spacecraft. The lights flickered. The cabin shuddered violently. Lovell looked out the window and saw a stream of gas venting into space. "Houston," Swigert said, steady but tense. "We've had a problem here." Lovell repeated, "Houston, we've had a problem. We've had a main bus be undervolt." Within seconds, telemetry on Earth lit up with warnings. One of the oxygen tanks had exploded. The second was rapidly leaking. In the vacuum of space, that meant one thing: the spacecraft was dying. Inside the control room in Houston, Flight Director Gene Kranz and his team scrambled for data. The command module Odyssey was losing power. Its fuel cells, dependent on oxygen, were shutting down one by one. Without them, the crew would soon lose light, heat, and air. Krantz made a decision that would define his career. Shut down the command module. Power it off. Move into the lunar module. The lunar module, called Sign Aquarius, had been designed to support 2 men for 2 days on the moon. Now it had to keep 3 men alive for 4 days in space. The crew sealed the hatches and transferred into Aquarius, which became a lifeboat adrift in the void. Temperatures inside dropped rapidly. Frost formed on the walls. Water was rationed to mere sips. Every breath produced more carbon dioxide, and soon their filters were failing. On Earth, engineers raced to find a way to save them. In one of NASA's most famous moments, flight controllers dumped a pile of random equipment on a table, hoses, duct tape, plastic bags, and built a working CO2 scrubber using only what was available on board. It worked. Meanwhile, the crew navigated manually, using the Earth's limb, its glowing blue curve, as a reference to guide their trajectory. They looped around the far side of the moon, farther from Earth than any human beings had ever traveled, and began their long, cold journey home. In Houston, Krantz gathered his exhausted team. Let's work the problem, people. Let's not make things worse by guessing. He ended with words that became legend. Failure is not an option. For 4 endless days, the world watched and prayed. Churches rang bells, schools held vigils, and headlines screamed updates from deep space. Every hour, every breath, every watt of power was measured and rationed. At one point, condensation was so thick that the crew feared short circuits. They endured hunger, cold, and exhaustion, but they never gave up. Finally, on April 17th, the capsule re-entered Earth's atmosphere. The heat shield held. 3 parachutes deployed, bright orange against the sky. And then, splashdown, the Pacific Ocean erupted in foam. Cheers erupted across mission control. The impossible had become possible again. NASA had brought its crew home, alive. Jim Lovell's words, calm but filled with awe, summed up the experience. We never landed on the moon, but we came home. Apollo 13 was officially a failure, but it became NASA's greatest triumph of teamwork, ingenuity, and courage. It reminded the world that space was not conquered, it was survived. Yet even as the agency celebrated, the truth was clear. The golden age of the moon landings was nearing its end. The public's fascination was fading. Budgets were shrinking. And though 3 more landings awaited, the glory of Apollo was beginning to dim. Still, before the program's final chapter closed, there would be beauty, danger, and discovery. Moments that proved exploration was never about glory at all, but about the unbreakable human will to reach farther. The next mission, Apollo 14, would rise from the shadow of disaster to restore NASA's confidence and send an aging hero back to finish what he had begun. Part 13, Apollo 14, a return to the moon, February 1971. The world's eyes once again turned toward Cape Kennedy, though this time with more quiet respect than roaring excitement. After the near-death ordeal of Apollo 13, NASA had rebuilt, reevaluated, and redefined what it meant to go to the moon. Every bolt, every wire, every line of code had been reviewed and tested. The agency could no longer afford even a single mistake. And at the center of this mission stood a man who embodied that resolve, Alan Shepard, the very first American in space. 10 years earlier, Shepard had risen to fame aboard Freedom 7, his suborbital flight lasting barely 15 minutes. Then came a long exile. An ear disorder grounded him for nearly a decade. Now, thanks to experimental surgery, Shepard was back, older, grayer, and more determined than ever. Apollo 14 would be his redemption. His crewmates were Stuart Roosa, the command module pilot, and Edgar Mitchell, the lunar module pilot, both highly trained, both aware that their commander was carrying the pride of a generation on his shoulders. The Saturn V launched on January 31, 1971, its familiar roar lighting up the Florida sky. Inside the spacecraft, Shepard's calm voice sounded over the radio, "We're on our way to the moon." But almost immediately, the ghosts of Apollo 13 returned. During docking maneuvers in Earth orbit, The command module Kitty Hawk failed to connect with the lunar module Antares. Shepard tried again, nothing. For nearly 2 hours, he and Rusev fought to make the connection, knowing that without a proper seal, they couldn't even attempt a landing. Finally, after exhausting every possible maneuver, the latches caught. "Hard dock," Shepard shouted. Mission control erupted in applause. Apollo 14 was back on track. 3 days later, they entered lunar orbit. Shepard and Mitchell transferred into Antares and began their descent toward the Fra Mauro Highlands, the same site Apollo 13 had been meant to explore. But even as they began their descent, another problem appeared. A false abort signal was flashing in the computer, a glitch that could trigger the lander's engine to shut down mid-descent. In Houston, engineers scrambled. They quickly uploaded a manual override program, allowing Shepard to bypass the faulty circuit. It worked, but for a tense few minutes it felt as though fate was testing NASA one more time. Then, as the gray surface of the moon rose up to meet them, Shepard's voice broke through. "Contact light." Apollo 14 had landed. The terrain was harsh and steep, unlike the flat plains of Tranquility Base. Shepard and Mitchell climbed hills, collected rocks, and deployed scientific equipment. The most important was a device called the ALSEP, Apollo Lunar Surface Experiments Package, a collection of instruments to measure seismic activity, solar wind, and cosmic rays. Their goal was to reach the rim of Cone Crater, nearly a mile away, to gather rocks from the moon's deeper layers. But the journey was brutal. The heavy suits, the soft powder, the slope, all conspired against them. Their heart rates soared, their oxygen levels dropped, and dust clung to every inch of their suits. After several exhausting hours, they were forced to stop, just a few hundred meters short of their target. They didn't know it then, but their samples still contained what geologists wanted most: fragments from deep within the moon's crust. As their final task, Shepard decided to leave a personal mark. He reached into his tool bag, pulled out a makeshift golf club, a 6-iron head taped to the handle of a lunar scoop, and dropped 2 balls into the dust. Raising the club with stiff, clumsy arms, he swung once and missed. Then, with a small adjustment, he hit the second ball cleanly. It sailed into the gray horizon. "Miles and miles and miles," he joked. It was a simple human gesture, absurd, beautiful, and perfectly symbolic. Even on another world, man still found time to play. After 33 hours on the surface, Shepard and Mitchell rejoined Rusa in orbit and began the long journey home. Their mission had been a complete success. Precision landing, scientific data, and safe return. Everything Apollo 13 had been denied. On February 9, 1971, Apollo 14 splashed down safely in the Pacific Ocean. Shepard, once the first American to touch space, had now become one of only 12 humans to touch another world. NASA had proven that it could recover, adapt, and triumph again. But even as the cheers faded, engineers were preparing something even more ambitious, the most extended and scientifically advanced lunar mission yet. It would carry a new generation of astronauts, a lunar rover, and a bold plan to explore regions far more treacherous than any before. The next step in humankind's journey to the moon would be Apollo 15, the dawn of a new kind of exploration, where the moon was not just a destination, but a frontier. Part 14, Apollo 15. The Explorers of the Highlands, July 26, 1971. Once again, the Saturn V thundered to life, a pillar of fire rising from Cape Kennedy, carrying Apollo 15, the first of NASA's Gemini missions. This was no longer just about reaching the moon and returning. It was about staying there, about exploration, science, and pushing the limits of what humans could do on another world. The crew of Apollo 15, David Scott, James Irwin, and Alfred Wardens, were not just astronauts. They were explorers in the truest sense, trained in geology, engineering, and survival. Their destination: the Hadley-Apennine region, near the eastern edge of Mare Imbrium, a landscape of towering mountains, deep valleys, and craters billions of years old. If earlier missions had been about courage, Apollo 15 was about curiosity. The spacecraft reached lunar orbit 3 days later, and on July 30th, Scott and Irwin descended in the lunar module Falcon, leaving wardens behind in the command module Endeavour. Their landing was the most precise and daring yet, touching down near the base of Hadley Rill, a massive canyon carved by ancient lava flows. As dust settled over their golden lander, Scott's voice came through mission control. "Okay, Houston. The Falcon is on the plane at Hadley." For the first time, the astronauts had something new, a vehicle. Folded inside the lunar module was the Lunar Roving Vehicle, or LRV, a small electric-powered rover designed to extend the astronauts' range. It unfolded like an origami miracle, its wheels popping open as they assembled it on the surface. Within hours, Scott and Irwin were driving across the moon, bouncing over rocks, leaving long tracks in the dust, and laughing as they felt the strange, delayed suspension of 1/6 gravity. The rover changed everything. What had once been a slow, grueling crawl on foot was now a journey of kilometers. They visited the Apennine Front, the rim of Mount Hadley Delta, and the edge of Hadley Rill, collecting rocks that would later reveal the moon's violent geological past. Among the samples was a piece of stone unlike any other, a gleaming white fragment that seemed older than the rest. Back on Earth, scientists would date it at over 4 billion years old, earning it the name Genesis Rock, a relic from the moon's primordial crust, a clue to the earliest days of the solar system. But Apollo 15 wasn't just a geological mission. It was also a spiritual one. As the days passed, Irwin, a deeply introspective man, felt something profound stirring within him. Surrounded by silence, staring at the distant Earth hanging in the black sky, he later said, "I felt the presence of God more strongly up there than I've ever felt on Earth." Their work was relentless, over 18 hours of exploration in 3 separate moonwalks, collecting 77 kilograms of samples and deploying an advanced scientific station. They even left behind a small plaque honoring fallen astronauts and cosmonauts, along with a tiny aluminum sculpture called the Fallen Astronaut. On the third and final day, Scott performed a simple but powerful demonstration. Standing before the camera, he dropped a hammer and a feather at the same time. They hit the lunar surface simultaneously, perfect proof of Galileo's theory that all objects fall at the same rate in a vacuum. "How about that?" Scott said softly. It was a quiet moment, one of science and poetry intertwined, broadcast live to a world that still couldn't quite grasp what it was seeing. After more than 3 days on the moon, Scott and Irwin lifted off, rejoining wardens in orbit. Before returning to Earth, wardens performed a solo spacewalk, the first ever conducted in deep space, to retrieve film canisters from the service module's cameras. His voice, calm and steady, echoed across the void as Earth grew in the distance. On August 7, 1971, Apollo 15 splashed down safely in the Pacific Ocean, completing one of the most successful missions in NASA's history. It had lasted 12 days, covered nearly 30 kilometers of lunar surface, and brought back a treasure trove of data that would redefine our understanding of the moon. But even as the scientists celebrated, one truth became clear. The moon was no longer a mystery. Each mission brought diminishing returns and growing costs. The public's attention was fading, budgets were shrinking, and politicians were beginning to look beyond Apollo. Still, 2 final missions remained, each with its own story of triumph, challenge, and the bittersweet realization that an era was ending. Next would come Apollo 16, a journey to the rugged highlands, a mission of science, perseverance, and quiet rebellion. And after that, one final voyage, Apollo 17, humanity's last footsteps on the moon. Part 15, Apollo 16. Into the Descartes Highlands, April 16, 1972. The world had stopped watching. Television networks no longer carried live coverage of every launch, and newspapers treated moon missions like routine flights. But for the men of Apollo 16, there was nothing routine about what they were about to do. Their destination, the Descartes Highlands, was one of the most mysterious and rugged regions of the moon, a place scientists believed could reveal its volcanic past. No mission before had dared to land in such rough terrain. The crew, John Young, Charles Duke, and Thomas Ken Mattingly, knew the risks. Young was a legend among astronauts. Calm, fearless, and methodical. Duke had been the Capcom, capsule communicator, who had famously told Armstrong and Aldrin, "You got a bunch of guys about to turn blue. We're breathing again." Mattingly, once grounded from Apollo 13 due to measles exposure, was finally getting his chance to fly. The Saturn V lifted off in a blaze of light, the sound rolling across the Atlantic like distant thunder. The launch was flawless, but the mission that followed would test NASA's confidence like few others. After 3 days, Apollo 16 entered lunar orbit. The lunar module Orion, with Young and Duke aboard, detached from the command ship Casper. Mattingly remained in orbit, running experiments and photographing the surface below. But as Orion prepared to descend, trouble struck. Telemetry showed that Casper's main engine, crucial for the return to Earth, was behaving erratically. Without that engine, the mission could end in disaster. Mission Control halted the landing. For hours, the astronauts waited, suspended in orbit, as engineers debated. Finally, after a tense night of diagnostics, NASA gave the word. The problem was not critical. They could proceed. "Your go for landing," came the call from Houston. Young and Duke began their descent. The terrain below was treacherous: craters, boulders, steep slopes. Dust swirled violently around them as Orion's descent engine fired. The surface came rushing up. "Contact light," Duke shouted. "Shut down." "We're here, Houston." "Fantastic." Apollo 16 had landed. The Descartes Highlands stretched around them, a landscape of pale gray ridges and fractured plains. Unlike the smooth Maria of previous missions, this was raw lunar geology, ancient and uncharted. For 3 days, Young and Duke explored the surface using the lunar rover, driving nearly 27 kilometers, farther and faster than any crew before. They climbed hills, took core samples, and deployed instruments. The rover bounced and skidded in the low gravity, often kicking up plumes of dust that hung motionless in the airless sky. The workload was exhausting. The bulky suits made even simple tasks grueling. Yet between the fatigue and scientific rigor, the two men found moments of childlike joy. At one point, Duke dropped a family photo encased in plastic onto the surface. A picture of himself, his wife, and their 2 sons. "That's for the Duke family," he said, smiling behind his visor. To this day, that photo still lies there, slowly fading in the harsh lunar sunlight. The mission was not without tension. During one moonwalk, the astronauts accidentally damaged a cable on the Alsop Science Station, nearly disabling one of its main experiments. Later, a jam drill refused to release a sample core. But despite these setbacks, Apollo 16 gathered over 95 kilograms of rock, evidence that the Descartes region was not volcanic as once thought, but composed of ancient highland material. Each night, as the astronauts rested inside Orion, they could see Earth rising, a glowing blue and white orb against the eternal black. Duke later said, "It was so small, so fragile looking. You realize how precious it all is, how thin the line is that keeps us alive." After 71 hours on the surface, they fired Orion's ascent engine and rejoined Mattingly in orbit. Before leaving lunar space, Mattingly performed a solo EVA, retrieving film canisters from the service module's cameras, the second deep space spacewalk in history. On April 27, 1972, Apollo 16 splashed down safely in the Pacific Ocean, marking another triumph in NASA's most challenging mission yet. But even amid the celebration, one truth was becoming undeniable. There was only one flight left. Budget cuts, political fatigue, and shifting priorities were closing the chapter on the Apollo era. One final mission, Apollo 17, had been approved. After that, the launch pads would fall silent, the Saturn V retired, and humanity's footprints on the moon would remain untouched for generations. The last mission would have to represent everything Apollo stood for: courage, discovery, and the eternal hunger to know what lies beyond. Its commander, Eugene Cernan, knew it better than anyone. He would become the last man to walk on the moon, And when he left, he would not just mark the end of a program but the end of an age.